Okay, on your Cornell notes, titled it Multiplying Integers. Multiplying Integers. Okay, our objective, our standard for today, we're still looking at the number system, and we're going to be working on multiplying integers today. We're still focused also on the math practice standard number 5, which is use appropriate tools and strategically. Okay?
Yes, Mr. Q.
All right. With that said, our objective for today, I can multiply integers. Let's read together. 1, 2, 3. I can multiply integers. So, by now you should know what integers are. So, therefore, fill out your Ferrier model by yourself. Integers. Focus, please. We've been dealing with integers for the past 2 weeks, so hopefully you already know what they are. So write your definition, example, non-examples, and critical attributes. I'll give you guys about 1 minute. Go. Okay, let's see. Definition. Integers are whole numbers including their opposites. Examples. Oh, it's frozen. My bad. Non-examples. Critical attributes are whole numbers and opposites.
I got that.
So by now, hopefully everybody got that, right?
Yes.
Okay? All right. So steps. Underneath that, write these steps down, please. Step number 1, or to multiply integers, I identify if the result is a positive or negative. Identify if the result is a positive or negative. Identify if the result is a positive or negative. Identify if the result is a positive or negative. Identify if the result is a positive or negative. Identify if the result is a positive or negative. Identify if the result is a positive or negative. Now that one, make sure you do, because a lot of you are still making little mistakes with the positives and negatives, so make sure you get that done at the beginning. From there, step 2, compute the numbers, which means multiply. Compute the numbers, which means multiply. And number 3, simplify. And this is a refresher in parentheses. If both numbers have the same sign, the result is positive. And we're going to go over a couple of examples so we can...
So if it's negative times a negative is positive?
Right. Give you guys another 30 seconds to copy this, please. Go. Alright, here we go. We good up to right there?
Yes.
Okay, so check this out. Pens down, eyes up here, and Carlos, can you get the lights, please? Let me play you our intro. Here it goes. Yes, here it goes.
Why does the panda fall off the tree?
As a biologist, I get to have a lot of fun spending time outside at places like the Everglades and studying some really cool animals. But for my job, I need to use math all the time, and that includes multiplying and dividing integers. In our study of alligators, we want to keep track of how many there might be in the whole river system we study. But the river system is too big to survey the whole thing. But using math, and a couple nights of counting alligators with spotlights, we can figure it out. Here's how it works. We sampled just part of the river. Tonight, we're going 10 kilometers. For part of our study, we catch alligators to collect important samples. Now let's say we count 20 alligators. We can divide 20 gators by 10 kilometers. That's 2 gators per kilometer of river we sampled. Now, to see how many we probably would see in 40 kilometers of river, we do a quick multiplication, and that's 80 gators. We also use integers to keep track of population decline. For example, if the next time we go out, we only count 18 gators, that's 2 fewer than our current sample, which we can represent as -2. Divide by 10, and the change is -0.2 to -2/10. Another bit of multiplication, and that's a decline of 8 alligators in the length of the entire river. Luckily for alligators, populations have been doing well, but we still keep monitoring. And that's another reason math matters.
Boom. Lights, please. Okay, so once again, notice that for every module they're going to have a video. And like I said, those of you that already are using your textbooks in that regards going to that website, there's certain things already available. I'm going to give you a code, hopefully by the end of this week, so that you guys have access to the electronic version of your textbook. So you can actually, instead of having your textbook open, if you're going to be on the computer, let's say doing another assignment, but you want to use a computer to see the text, you should be able to see it on the screen, kind of like what I showed you. Does that make sense? All right, so with that said, to get us started, we're going to do a quick explore activity. And what I want us to do is continue using tiles, so that you can see how tiles are used in order to multiply numbers. So, with that said, copy this one down, please. Example 1, 1A, 1B, and 1C. Yeah. Now we said that the rule was what? That if they have the same sign, the answer is positive. Okay. So let's do the first one together. Change this to multiplication, I'm sorry. There it is. So it's 35 times negative 5. Are these the same sign?
No.
No. So therefore the answer is a negative. So we need to do that at the beginning. Don't leave it at the end, because then you're going to forget the signs. Does that make sense? Now we just multiply. Step 2, compute 35 times 5. 5 times 5, that's 25. We got 2. 5 times 3 is 15 plus 2, 17. So that's 175. Can we simplify that anymore? No. Let's see the 3 steps. Step 1, identify if the result is a negative or a positive. Yes, we did that. Step 2, compute. Yes. Step 3, simplify, and we're done. Okay? Do these by yourself. Go. Okay, let's see. Number 1B, volunteer for this one. Jose. Okay, walk me through the steps. What is the first thing to do? Check if the result is a... So what is the result? Why? It's a positive because they have the same sign. Okay, step 2, what do we do? Compute. So then it's 11 times 4, and what did you get? Can we simplify that anymore? Can we simplify this anymore? No. And we're done. Hands if you got that. Okay. Number 1C. Go ahead, Andrew. Step 1. If it's going to be a negative or positive, and you said it's a what? Negative. Why?
Because
They're not the same sign. And then step 2. 6 times 7 is 42. Hands if you got negative 42. Okay. We got this, right? Okay. Now let me show you how to do some of this with tiles. So for this next one, I want you to write example 1Q. Example 1Q. Copy this. 3 times negative 2. Just copy it. You don't need to write anything down. I'm going to walk you through this one, okay? Alright, pens down. Writing utensils down. Eyes on the screen. Here it goes. I'm going to use tiles for multiplication. Check this out. First of all, first thing to do is, what do we have inside of the parentheses? It's what? Negative 2. So I'm going to do this. I'm going to show first what I have inside of the parentheses. Is that what you say we have inside the parentheses?
Yes.
Yes. However, this number is going to tell us how many times we repeat that. So how many times are we going to repeat negative 2? 3. So it's negative 2, negative 2, negative 2. Therefore, what do you see? Do we have any zero pairs? No, so what do you see? Negative 6. You have to see what we did there. That's using tiles. Now let me show you using the number line. Here we go. So I'm going to start at 0. So this, in the parentheses, says that I need to take a jump of negative 2. Everybody look up. A jump of negative 2. However, how many times am I going to do that? 3. That's 1, 2, 3. So let's see. The first jump was at negative 2. Where do I land on the second jump? That's negative 4. And on my third jump, I land where? Negative 6. And that's how we use tiles and the number line. Copy that, please, and I'm going to give you one for you to try. Okay. Okay. And for those of you that are already done, I'm going to post the next one. Example 1, super Q. Here we go. 2 times negative 6. Show me with tiles and the number line. I will give you guys some time. What's inside of the parentheses? Negative 6. So I need to show that with tiles. 1, 2, 3, 4, 5, 6. But how many groups are they asking us to do? 2. There's 1, and here's another. So how many total negatives do we have? Negative 12. Hands if you got that. Okay? Now with a number line. Here he goes. I start at 0. And it says to do a one jump of how much? Negative 6. Negative 6. But how many times am I going to jump? Twice. So what do I land on the second jump? Negative 12. That is correct. So far so good? Okay, so now check this out. Let me show you this next one. Example mega cube. Let's do 3 times 9. Show that with tiles and show that with a number line. I'll give you guys about 40 seconds. Go. Okay, here we go. What's inside of the parentheses? 9, and it's a positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you guys see 9 positive? Yes. But how many times does it tell us to do the groups? 3 groups. So we got, that's 1, 2, 3 groups of 9. Do we have any zero pairs? No. So the answer would be 27 positives. Are we there? Using the number line. I start at 0. And my first jump is 9. But how many jumps do we need? 3. So 9, the second one is 18, and the third one is 27. Hands if you got that by yourself. Okay? So now, check this out. I'm going to show you another one. It's going to look kind of weird. Example super duper Q. Check this out. We got negative 3, open parentheses, 4. Just copy it, and now I'm going to go over that one. Okay.
It's easy. We're just going to do positive 4 for 3 times.
Okay, everybody look up, please. Check this out. This is a positive 4, is that correct? Okay? And if I was to show the positive 4s, it would look like this. It says 3 times. However, who notices that this one has a negative? Okay? So check this out. This is what happens. Whatever I start with, and if this is a negative, it switches the signs of all of these. So what sign am I going to switch to? Negative. So therefore this becomes a negative, 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 negative. All of them switch to negative. So what do we have now? Negative what? Negative 12. Let's see if it works with the number line. Pay attention before you copy this. Just pay attention. Here it goes. I start at 0. And I'm supposed to take one jump of 4 this way. Is that correct? However, look up please. And this tells me to take 3 jumps. Are we there? 1, 2, 3, or 4. But whenever it has a negative, instead of going to the right, I'm going to go to the left. So I'm going to take 3 jumps of 4 to the left. 1, 2, 3. So I'm at, the first jump is negative 4, the second jump is negative 8, and the third jump is negative 12. Copy that, please. Are we there so far? So make a note for yourself right here. Asterisk, heart, aww. When the first factor, which is this one, this is the first factor. When the first factor is a negative, I switch the signs of the tiles. How about on the number line? What do we do when the first factor is a negative? You switch to what? No, on the number line. You switch the direction. Yeah. So on the number line, I switch direction. How we doing? All right? Okay. Now, we already know that, everybody look up please, check this out. Pens down, eyes up here. I'm going to do an Explorer demo really quick. I need you guys to just think on this one. Pay attention please. If I was to say 1 times negative 1, what is the answer? Everyone? Times negative 1, it's negative 1. Are we there? Why? I already showed you that because what's inside of the parentheses, it's a negative, and it tells me to only do it 1 time. That's how I get a negative 1. Are we there so far? However, this is what I want to do. I want to show you why, if we look up, I want to show you why negative 1 times negative 1 is positive 1. This is what I want us to pay attention to. Are we there? We know this is true because I showed you with tiles, yes? But I want you to understand why this becomes this. So here we go. Pay attention. I'm going to start with 0 equals negative 1 times 0. Does everybody agree that 0 is negative 1 times 0? Yeah, right? Because any number times 0 is 0, right? However, check this out. 0 equals negative 1 times. I'm going to write a zero pair. Check this out. Negative 1 plus 1. Think about it. Is negative 1 plus 1 equal to 0? Yeah, right? Negative 1 plus 1 is equal to 0. Is everybody agreeing so far? Okay, so now check this out. My next step, I'm going to apply distributive property. I'm going to distribute this negative 1 in here. Watch. Negative 1 times negative 1 plus negative 1 times 1. And all that is equal to 0. So now let me ask you a question. 0 stays the same. The equal sign stays the same. What is negative 1 times 1? What did we say that was? Negative 1. Are we there so far? Okay, so you agree that these two are this, right? Plus. Now let me ask you a question. Pay attention, please. Here goes the proof. What number plus negative 1 equals 0? Don't say it out loud. What number plus negative 1 is equal to 0? What number plus negative 1 is equal to 0? Tell your neighbor, please. Okay, so if we look up, by looking at this equation, you said that 1 plus negative 1 is 0. Is that correct? But what did we have here in this space? What was here? Negative 1 times negative 1. So what are we saying? That negative 1 times negative 1 is what? Positive 1. So we just proved it by using the opposites here. Definition of opposites. Are we there so far? Okay. So I just wanted to get your noodle thinking around in regards to this regard. So let's go to our text. Get your textbook out, please. Okay, I want you to do, look up please. I want you to turn to page 38. Follow these examples that they give you. I already did the explore activity with you. See if you can fill in the blanks, please. Follow the way 1 through 3, please. Okay, so we're finished with that page. Let's keep going. I want you to go to page 40. Start from the top where it says your turn, and then continue down those practice problems. I'm going to give you guys a little bit of time. And we have about 3 minutes, so within those 3 minutes you should be done with at least number 7 all the way to at least number 6. Go. Guided practice, guided practice. Go. Oh, and before I forget, homework for tonight is found on pages 41 to 42, number 17 to 27 odds. Once again, it's more about answering questions about concepts. I want to see what you guys are thinking. So make sure, read the entire problem and read the question out so that you understand what you're doing. Okay? So continue working. I'm going to stop the video and enjoy your homework, guys. See you guys. Tomatoes.